Imagine for a second you're coaching soccer, or maybe you're a young player yourself, always looking for that extra edge.
hmm
You're training hard, really putting the effort in. But how do you actually know if it's the right kind of effort? Is it really hitting the mark for performance?
Yeah, that question really gets to the core of it, doesn't it? In sports science, we're always trying to figure out how athletes really adapt and improve.
Right.
It's not just about how much you train, but more about, well, what kind of training load actually moves the needle.
Exactly. And that's what this deep dive is all about. You brought us some really interesting new research, and we're going to unpack the key insights, maybe some surprising stuff too.
That's the plan.
Okay, so today's deep dive focuses on a specific research article. It's called Effects of Different Training Load Parameters on Physical Performance Adaptation in Soccer Players. How Complex Intensities Influence the Magnitude of Adaptations. Quite a title.
It is, yeah. It's by ZhiFeng Xiong, and it was published in the Journal of Sports Science and Medicine. That's volume 24, pages 475 to 484.
And you've got the DOI for anyone who wants to track it down.
Absolutely. It's https://doi.org 10.52082JSM.2025.475. And what's really great about this paper is how current it is.
Oh, how so?
Well, it was only received by the journal in April 2025, accepted in June, and then published online September 1st, 2025. So we're talking really fresh research, very relevant.
Excellent. Okay, so let's lay the groundwork. This term training load, what does it actually mean in sports science? It sounds simple, but I get the feeling it's more complex.
You're right, it definitely is. It's what we call a multidimensional construct. Think of it in two main parts.
Okay.
First, you have external load. This is the objective stuff, the measurable work the athlete does. Things like, how far they run, how fast, how many accelerations. It's the actual physical output.
The work done. Got it.
Exactly. Then second, you have internal load. This is about the athlete's response to that work, the physiological stress, the biomechanical strain.
So how the body reacts.
Precisely. Things like heart rate, or maybe how hard the athlete feels they're working. That's often measured using RPE, ratings of perceived exertion.
Okay, that makes sense. External is the work, internal is the body's reaction to it. Now, the article mentioned this ongoing debate. Some questioning load metrics, others defending the concept. What's that about?
Yeah, that's a really important point. It boils down to the difference between just finding an association versus finding a cause.
Explain that a bit more.
Well, in science, especially sports science, we're aiming for what's called a causal dose-response relationship. We want to know if changing the training dose, like adding more high-speed running, directly causes a predictable change in the outcome, like better sprint times.
Not just that they happen together sometimes.
Exactly. It's easy to find correlations, things that happen at the same time. But finding what actually causes the adaptation, that's the tricky part, and that's the real goal.
Right. So, with that in mind, let's look at this specific study. It wasn't done in a lab, was it? It sounds more real world.
Very much so. It was designed as a 12-week cohort study. They followed 41 male soccer players, all under 17s, average age about 16 and a half.
Right.
They were all outfield players, had at least 3 years experience playing regionally. And the key thing is the researchers worked with 2 actual amateur teams in their normal environment.
So an ecological environment, as they call it.
Precisely. They didn't step in and change the training plans. They observed what happened naturally over those 12 weeks.
Observing, not controlling. So how did they track everything? What did they measure?
They used a mix of tools. For that internal load we talked about, they used heart rate monitors during sessions and also asked players for their RPE using the standard CR10 Borg scale after each session.
Okay, heart rate and perceived effort for internal load. What about external?
For external load, they relied on GPS devices. These tracked things like the total distance covered, but also specific intensities like high-speed running or HSR.
Which they defined as?
Defined as running between 14.0 and 19.9 kilometers per hour, and also very high-speed running, VHSR, which was anything over 20 kilometers per hour.
Got it. GPS for the work output. And how did they measure if the players actually got fitter?
They did fitness tests at the start, baseline, and then again after the 12 weeks. They looked at several things. Aerobic capacity, using the yo-yo intermittent recovery test, or YIRT.
Yep, familiar with that one.
Anaerobic capacity via the running-based anaerobic sprint test, specifically the mean sprint time, RS-EMIN. Muscle power using a counter-movement jump, CMJ. And just pure speed with a 30-meter sprint test.
Okay, comprehensive testing. So let's get to the results. What did they find about improving endurance, that aerobic capacity?
This is one of the really strong findings. They found a significant positive link between the internal load measures and improvements in that yo-yo test performance.
So higher internal load meant better aerobic games.
Exactly. Specifically, both the accumulated session RPE,
Oh.
so how hard players felt the sessions were over the whole 12 weeks, and accumulated TRIMP were strong predictors of wire improvement.
Can you quickly remind us what TRIMP is?
Sure. TRIMP stands for training impulse. It's a way to calculate training load using heart rate data, factoring in both the intensity and duration of the exercise. It gives a single score for the physiological stress.
Okay, so session RPE and TRIMP, both internal measures, linked strongly to better endurance. Why is that? Why are these internal markers so important for aerobic fitness?
Well, it's thought that measures like session RPE and TRIMP capture the overall stress on the body's systems, cardiovascular, respiratory, even neuromuscular. They reflect the integrated response. This kind of stress is what stimulates those key aerobic adaptations. Centrally, things like your heart getting stronger, pumping more blood per beat, increased stroke volume, cardiac output, and peripherally in the muscles themselves, like more capillaries, more mitochondria.
Which helps get oxygen to the muscles and use it better.
Precisely. Better oxygen delivery, better utilization. So for a coach wanting to boost endurance, focusing on ensuring athletes achieve a sufficient internal load, measured perhaps by RPE or TRIMP, seems really key, according to this study.
That really underlines the value of listening to the athlete's perception and monitoring their physiological response, not just the external work. Okay, what about the flip side, speed and anaerobic stuff?
Right, so thinking about things like repeated sprintability or RSA, here the story shifted towards external load, but specifically one type.
Oh, which one?
Accumulated very high speed. Running that VHSR, running faster than 20 kilometers per hour, was a significant predictor of improvements in their repeated sprint times.
So more time spent sprinting really fast led to better repeated sprint performance.
Yes. Specifically, higher accumulated VHSR was associated with better RSA times, meaning faster average sprints during the test.
And what about the high-speed running, the HSR range just below that?
Interestingly, HSR, the 14.0 to 19.9 kilometer range, was not a significant predictor for RSA improvements in their models.
Wow, okay. That's a really specific finding. VHSR mattered for repeated sprints. HSR didn't seem to as much. Why might that be? Is there like a threshold effect?
That's exactly what it suggests. It seems that hitting those very high speeds, the VHSR zone, might cross a critical threshold needed to really stress the anaerobic systems involved in repeated sprinting.
Like the energy systems.
Yeah. The thinking is, at VHSR intensities, the demand probably shifts heavily towards the anaerobic glycolytic system. This forces the muscles to get better at producing energy quickly without oxygen, maybe through increased enzyme activity, and also better at handling the metabolic byproducts, like lactate.
Improving buffering capacity.
Right, which is crucial for recovering between sprints and maintaining performance. Now, the authors are careful to say this mechanism is a bit speculative based on their data.
They didn't directly measure enzymes or buffering.
Correct. But the link between VHSR exposure and RSA improvement was statistically significant. It strongly implies that intensity matters, and perhaps only the highest intensities drive this specific adaptation.
Okay, that's fascinating. Internal load for aerobic. Very high external load for repeated sprints. But here's something that stood out as surprising in the paper. What about basic sprint speed, the 30-meter dash, and jumping power, the CMJ?
Yeah, this was unexpected. Despite players generally getting fitter, the study found only weak or non-significant relationships between the training load parameters. They tracked both internal and external, and improvements in the 30-meter sprint and the counter-movement jump height.
Huh. Why would that be? Any ideas from the paper?
They discuss a few possibilities. Sprinting and jumping rely heavily on neuromuscular factors, explosive power, rate of force development.
Things develop differently.
Potentially, yes. These qualities are often better targeted through specific types of training that might not be fully captured by just looking at total distance or even time spent in speed zones during general soccer training. Think dedicated weight room work, strength training, power training, or very specific plyometrics or sprint drills.
So the measured loads might have missed the key stimulus.
Exactly. The paper suggests factors like maybe the number of maximal long sprints or powerful accelerations could be more important drivers for improving pure sprint speed and jump height than the broader load metrics they used. It highlights that different fitness qualities likely need different, very specific training stimuli.
That makes a lot of sense. It's not just one load dial you turn up for everything.
Yeah.
Okay, let's synthesize this. What are the practical takeaways? If you're a coach, an athlete, or just, fascinated by this stuff, what should you take away from this deep dive?
I think there are some really clear, actionable points here. For aerobic fitness, for building that endurance base, the focus really seems to be on monitoring and managing internal load. Accumulated session RPC and TRIMP look like valuable guides to make sure athletes are getting enough stimulus.
So check in on perceived effort, track heart rate zones, and duration.
Right. But for improving the ability to repeat sprints, that RSA, the key, seems to be hitting those high external load intensities, specifically very high-speed running. Coaches should probably ensure sufficient exposure to that 20-kilometer zone.
Target the right intensity for the right goal.
Precisely. It's about being more specific. By tracking these different internal and external load variables, coaches can potentially fine-tune training much better. They can aim for that sweet spot, pushing enough to get adaptations but avoiding harmful overreaching. It's about smarter training design.
Smart, targeted training, love it. Now, as with any good research, we need to talk about the context, the boundaries. He mentioned the authors were transparent about limitations.
Yes, absolutely. Good science always acknowledges its limits. It's crucial for interpreting the findings correctly.
So what was the fine print on this study?
Well, first, they noted they only measured certain load variables, SRPE, TRIMP, total distance, HSR, VHSR. There are others out there, like heart rate variability, maybe muscle oxygenation, that weren't included but could also be relevant.
Okay, so they didn't capture every possible load metric.
Correct. Also, as we touched on, while they found the link between VHSR and RSA, the exact reason why the physiological mechanism is still a bit speculative and needs more direct investigation.
Right. The why needs more work.
And a big one is the study design. Because it was an observational cohort study, watching players in their natural environment, it's hard to definitively claim cause and effect. They found strong associations, but you can't be 100% sure the load caused the change without a controlled intervention study.
Correlation isn't causation, the classic reminder.
Exactly. They also mentioned using convenience sampling, meaning they worked with readily available teams. While they use two different teams, which helps, it might limit how perfectly you can generalize the findings to all U17 regional players everywhere.
Okay. Who else?
They also couldn't control for other factors that definitely influence training adaptation, things like nutrition, sleep quality, even psychological stress. These are important confounders.
Yeah, huge factors in real life.
For sure. And because it was observational with different teams, there was naturally some variation in how the teams trained. Finally, the sample was specific. Youth male soccer players. So you need caution applying these exact findings directly to, say, female athletes, older players, or different sports.
Makes sense. Demographics matter.
And they also mentioned the sample size, 41 players. While statistically significant findings emerged, larger studies could provide even more robust confirmation and reduce the risk of what's called overfitting in the statistical models.
Okay, so important caveats to keep in mind. But even with those limitations, this study really paints a compelling picture, doesn't it? It feels like it pushes us towards a more nuanced understanding of training.
I think so too. It highlights this dynamic interplay between internal feelings and physiological responses and specific external actions like high-speed running. It really gives coaches and athletes more specific things to think about and potentially track.
It feels like a step towards more personalized training, tailoring the work not just generally, but for very specific goals based on whether you need aerobic power or that repeated sprint ability.
Absolutely. It's moving away from just train hard towards train smart, identifying the specific stimulus needed for the desired adaptation. It's a very promising direction.
Well, this has been fascinating, but we've really only scratched the surface of the detail in ZhiFeng Xiong's research.
Definitely.
So, if your interest is piqued, we strongly encourage you to read the full article. Again, it's Effects of Different Training Load Parameters on Physical Performance Adaptation in Soccer Players, published in the Journal of Sports Science and Medicine.
It's worth the read if you're serious about understanding these concepts. We hope this deep dive gave you some valuable insights and practical things to consider for optimizing performance.
And please, make sure you follow our channel and turn on those notifications. That way, you won't miss out on our future deep dives into more cutting-edge research like this.